Area of a circle increases at a rate of 20 inches squared per minute. At what rate is the radius increasing when the radius is 5? What the heck is it even asking? I'm going to draw a box. And in this box, I like to organize my thoughts. And in this box, I like to kind of model the problem as a whole. Okay? And so I have a circle that is getting bigger. Okay? Derivatives at heart are about change. Things are changing. What is changing with respect to the circle? What else? Radius, circumference, area, volume. No volume because it's a two-dimensional figure, but a diameter. I mean, all of that is changing, agreed? It's all changing, okay? And it's changing with respect to something in particular. There's something else that's changing in this problem that you have not yet mentioned, and it doesn't have to do with the circle. Time. All of them are changing with respect to time. You see that? And so when we speak of related rates, most of the time we're talking about the rate that they're related to is none other than time. So far, we've taken the derivative with respect to x all the time. But now we're taking the derivative with respect to time. Here's where I model the problem. And here is where I write kind of my formula. I also like to write my knowns. Whoop. And unknowns. Okay, so what formula do you think we're going to use in this problem? Area of a circle is pi r squared. I don't give you the formula, area is pi r squared. So people ask, what do they do if they don't remember? I guess you get it wrong on the test. At this point, we expect that you know the area of a circle. And if you do not, then that is the measure of you as a math student. I don't know any other way to say it. Now, let's write down our knowns and our unknowns and what we're trying to find, okay? It says the area increases at that rate. That is a rate. Therefore, I know that A prime is equal to 20. It's saying at what rate is the radius increasing? If I'm looking at the rate, the radius is increasing. What variable do you think that is? R prime. R prime is what I'm trying to find. It says when the radius is 5. So that is R is just 5. Those are the things I know. That is the thing that I don't know. This is where I like to take my derivative. And I take the derivative with respect to time. The derivative of area equals pi r squared. And because it's with respect to time, this is where we consider implicit differentiation. So when you take the derivative of A, it's 1 times A prime. Does that register for people? Let me show you again. If you had the derivative with respect to x of the following, x squared plus y squared is equal to 10. Just remember that the derivative of x squared you said was 2x. That's because it matches with what you're taking the derivative with respect to. Whereas when you got to the derivative of y squared, you wrote 2y y prime because you're taking with respect to x, not with respect to y, so you need to attach a y prime every time. Remember that? And then the derivative of 10 was 0, and there's what we got. So in this situation right here, just notice that the derivative of a doesn't match with t, so it's a prime. is equal to, anybody want to guess what the derivative of 2 pi r squared or pi r squared is? 2 pi r prime. See it? Oh,
I've just been following along.
sorry.
That's right.
I think I might want to follow this. She's writing her notes on the bench.
Let me know where. Here we go. There we go. All right.
Yeah, there it is.
Sorry. It's just that time of year. I have people in and out of my class. Seems like every 3 minutes. So, okay, here we go. A prime. What is A prime? 20 is equal to 2 pi times 5 times r prime. Can we solve for r prime? Yeah, no big deal. We get 20 is equal to 10 pi r prime. So I go ahead and I divide by 10 pi, and I get 1 over pi is equal to r prime. And if you, we need to express that as a, hi.
Is it 2 over pi?
I'm sorry, 2 over pi r prime is equal to r prime. Somebody in their calculator, 2 divided by pi. .636, and radius is a linear dimension, so we're going to say that that is measured in inches per minute. Is that, are we per minute?
Yeah.
There you go. You got your rate. Not too bad? Okay. A basketball is being filled with air at a rate of 1 cubic centimeter per second. At what rate is the radius increasing when the radius is 12? Similar problem, different formula. Okay. I have a basketball. I'll try to do my best impression of a three-dimensional object, which is very poor. It is expanding. It is getting larger. Okay. What formula should I write down? What is the volume of a sphere? 4/3 pi r cubed. What are some things that I know? What in the problem am I given?
Radius
Radius is 12. V prime is 1. What am I trying to find? Trying to find R prime.
Why is it volume?
Because it's a basketball.
Because it's a basketball.
It's a 3D object, not a 2D object.
Oh, the last one was 2D?
It's
Yep.
a circle
Okay.
versus a ball.
Shut up, okay.
Those are the ones I'm talking about when he judges us. Those ones right there.
Lily, you're the one telling her. You judge me every time I get something wrong.
It's okay, let's keep going.
Yep. A lot of pointing fingers going on over here. So, all right. We take the derivative in this box. The derivative with respect to time of volume equals 4/3 pi r cubed. And the derivative of volume is V prime. When I find this derivative, I drop the 3 in front. What are you going to get?
4.
Pi r squared r prime.
Can you maybe explain the R prime thing one more time? So that's like when you have it with respect to x, and it's like.
Yeah, so the t doesn't match,
Yeah.
right? So if I try, let's say I did this, the derivative with respect to time of, let's say I had r squared plus t cubed, okay? And I want to take that derivative.
Yeah.
So it would be, the derivative of r squared would be 2r r prime because it doesn't match. But I have time, so that derivative is just 3t squared.
Okay.
So you will never have a situation here where you have the variable t. So you will always attach an r prime, an a prime, a v prime, anything of that nature, okay? So we've got that. We plug in our knowns and our unknowns. And what we have is 1 equals 4 pi times r squared, which is 12, okay, squared, times r prime. If I go to my calculator, I figure out what 4 times pi times 144 is. We're going to take 1 divided by that. 1 divided by that answer. And I get, I still need to multiply it by, wait, is that right?
Yeah.
So 5.5 times 10 to the negative 4th. As I go back to my annotate here, we get r is equal to 5.5 times 10 to the negative 4th. If you'd like to move the decimal point over, r prime is equal to 0.00055, and it is centimeters per second. Okay. Let's flip it over. I would like to get through these two problems as we leave you today. It says a right triangle has a base of 12 that remains constant while the height and area increase. The area is increasing at a rate of 8 centimeters squared per second. At what rate is the height increasing when the area is 64? I have a right triangle. I have a base of 12. The triangle is changing. What are some things that are changing in this problem? The height, area, I suppose perimeter, right? What is not changing? Okay, excellent point. It is the case that the angles are changing, but good thought, they are changing. What isn't changing? The base. This is constantly staying at 12. And so if it says the area is increasing at that rate, notice that we say area is equal to 1/2 base times height. As you think about this and plan ahead, if you were going to take that derivative, anybody know what rule we would need to use? The product rule, wouldn't we? Okay? And in this situation, when something isn't changing, you get to plug it in right away. See how before we waited to take the derivative before we plugged in what r was? If it's changing, you don't get to plug it in right away. If it isn't changing, you can plug it in right away because it's constant. So therefore, area is equal to half the base is going to be 6 times the height. And so I know in this problem that the current base is 12. I use that already because it's constant. And I know that a prime is equal to what? 8. And I know the current area is 64. Those are the things that I have in place. And so as I take this derivative with respect to time, I have the following. Derivative of area equals 6h. What's the derivative of a? A prime, and the derivative of 6h? 6h prime. Okay? It says at what rate is the height increasing? So we're looking for h prime. Okay, that's what we're looking for. And so I plug in a prime, which is 8, is equal to 6h prime. Did we need the fact that the area was 64 at all? Nope, not required. Divide by 6 and we get 4/3 is equal to h prime. otherwise known as 1.3, and it is centimeters per second.
Could we leave it in the fraction?
Sure, yep, that'd be just fine. Okay, last problem. An airplane is traveling east at 600 miles an hour. Another is traveling north at 750 miles an hour. If they left the airport at the same time, how fast is the rate of their distance apart increasing after 2 hours? I'd like to finish off this problem, but I don't know if we'll be able to. Got one plane traveling this direction at 600 miles an hour. Got another train traveling this direction at 750 miles per hour. And there is a distance between them that is, did everybody agree the distance is growing, it's getting larger? We'd like to know at what rate that distance is changing. Okay. I'm going to use the variable n to describe the distance north. I'm going to use the variable e to describe the distance to the east. Anybody think of an equation? Pythagorean theorem, and I would call this d. Namely that m squared plus e squared is equal to d squared. N squared plus e squared is equal to d squared. That's what we have. Which of these components do we know? We know n prime is equal to 750, and we know e prime is equal to 600. We're trying to find d prime. Could somebody tell me, when I take this derivative, what do I come up with?
N prime plus 2e e prime equals 2b d prime.
We got a lot more things there than what we found out, didn't we? Like we have something to plug in for n prime, and we have something to plug in for e prime, but we need to know n and e. Those are rates, those aren't distances. How am I going to figure out how far it's traveled to the east?
It's over 2 hours, so you can.
Over the course of 2 hours, how far will it have traveled to the east?
1,200.
1,200. How far will it have traveled north?
1,500.
1,500. Notice that we're also expected to find D. Could we find D?
Yeah.
If we know we have 1,200, 1,500, we use the Pythagorean theorem to figure out D. I'll do that. We have 1,200 squared plus 1,500 squared, and then I will take the square root of the answer. And I get 1,920.9. We'll finish that problem off tomorrow. There are some